So today we are looking at vector geometry and dynamics. It's a topic for all 100 level students, second semester, and also first semester, depending on your school. So we're looking at elementary mathematics 111, vector geometry and dynamics. It's also called MTH103 or MTH111, depending on the school coding. So let's go straight to some of the questions and see what we can get from it. The questions are in relation to vector and scalars, vector representation and types, addition and subtraction of vector, vector component and unit vector, magnitude and direction of vector, dot product and application, cross product and application. We also have vector problem in physics and geometry. We have coordinate geometry of a circle, definition and properties of circles, standard and general equation of circles, center and radius determination, complete the square, point, chord, and tangent, intersection of lines and circles, application of circles. Also have conic section, where you have parabola, focus, directrix, vectors, and its applications. So let's go straight to some of the questions we can base our hands on, which is very helpful to you. Stay tuned, follow, like, subscribe, and stay tuned. So let's look at question 1. So which of the following quantities classified as a scalar? Scalar quantities are measurable quantities that have magnitude but no direction. I believe we all know this definition right from exercise 1. The only scalar quantity here is surface tension. Displacement is vector, acceleration is vector, force is vector. So the correct option here is surface tension. Then let's look at question number 2. So given the vector A is the vector and B is the, find the resultant vector A and B. So A and B mean I have to sum both of them. I'm having A plus B. So what is vector A is given to us as this. So I'll write it first. 3i plus 2j minus 3k plus vector B 2i plus 3j plus k. So we are going to add the same variables together, I to I. I cannot add I and j, I will only add I to I. So 2i plus 5i plus 2i will give us 5i. Then 2j plus 3j, that will give us 5j. Then minus 3k plus k, here's 1k, that will give us minus 2k. So the answer is option A. That is the answer to the question. So let's look at question 3. It says compute the scalar or dot product of the vector. The scalar or dot product, can call it scalar product or use the word dot product. Meaning we have to multiply vector A. If the first one is vector A and second one is vector B, we have to multiply A dot B. It's different from A times B. A times B is cross products. So A dot B will give us vector A first, 3i minus 7j plus 2k, if I have to call the first vector A, dot second vector B, 2i minus 2j minus 3k. So we're going to multiply based on their vector sign, I to I, j to j, and k to k. I to j is 0, j to I is 0, k to j is 0, k to I is 0. So that's why we just go straight to I to I, j to j, and k to k. So if that should happen, I'm going to have 6 plus 14, which is 7j and minus 2j. Then 2k and minus 3k, that will give us minus 6. So minus 6 and 6 is 0. Our answer is 14, which is option B. So let's look at question 4. It says calculate the value of the vector if vector A and B is given 2a minus 3b. So 2a will give us 2 into vector A, which is 3i plus 5j minus 3 into vector B, 4i minus j. So all we need to do is to open the bracket. That should happen. The first bracket will give us 6i plus 10j. Square will give us minus 12i plus 3j. So we add them based on their sign. This is I, based on their sign. We add them based on their sign. I to I, j to j. So I'm adding 6i to minus 12i. That will give minus 6i. 10j plus 3j, that will give us 13j. So the option is minus 6i plus 13j, which is option B. So let's look at question number 5. Now look at question number 5. Say find the modulus of the 3D vector. 3D means it contains the 3 vector sign. Here is I, J, and K. 3-dimensional vector. So the modulus means the absolute value of the vector given to us. So modulus of R will be square root of 2 square plus 3 square plus minus 4 square. So anytime you are squaring a value, make sure you put it in square in bracket. Otherwise, if I just square minus 4 as an alone, will give me minus 16, which is wrong. So make sure you always put it in brackets. So if I square 2, I have 4. If I square 3, I have 9. If I square minus 4, I will have 16. So what do we have? We have the square root of 29. If you have to add up, I have square root of 29, which is option C. So let's see what we have here. We're asked to find the angle theta of the positive axis of this vector. We have the vector is 2 root 3i minus 2j. 3i minus 2j. So I have to determine the x. So the x is the I, which is our 3. But if this 2 should go in, it will go in as what? As 4. So I'm having 4 into 3i minus 2j. Okay. So same, this question is having an issue. Let me erase it. Let's do like a typing error there. You can see like something like division. So we're having 2 dividing root 3 for the I. Then here minus 2 minus we have root 3 over 2 for the I, and we have a root 2 over 2 for the j. So this is cosine direction, which is alpha. So which is root 3 over 2. So root 3 over that will give us 30 degrees. If you take it with root 3 divided by 2, which is 0.866, add cos of 0.866 should give us 30. So that is the answer to that question. Now say find the cosine direction of this. So cosine direction, now first of all we need to get the absolute value or the modulus of the vector. We are talking about the y direction now. I told you we have x, y, z. We have xi plus y j plus z k. Here they are looking for the y direction, the y axis. So I need to get the absolute value. So the absolute value of r will be square root of 2 squared. Like I said, always put it in brackets, minus 5 squared plus 1 squared. So if I simplify, 2 squared will give me 4. 5 squared is 25 plus 1, that is square root of 30. So the y here is minus 5. So I'm having minus 5 over the square root of 30, which is option B. Then number 8. Say evaluate the scalar scalar product, which is also called the dot product. We've done something similar earlier. So I'm going to have 7i plus 3j minus 4k dot 4i minus 2j minus k. So similar manner, I to I, j to j, k to k. So 7i times 4i, that will give us 28. 3j minus 2j, that is minus 6, minus 4k minus k, that is plus 4. So the answer will give us 20. This is minus 2, 26 is our answer. 26, option A. So I have to find the unit vector of what we have here. First of all, you have to find the absolute value. The unit vector of A will be vector A over absolute A. That will be our unit vector of A. Vector A over absolute A. We'll call it UA. So what is vector A? 4i plus 9j. Absolute A will be 4 square plus 9 square. So if I simplify that, I'm going to have 4i plus 9j over square root 16 plus 81. 16 plus 81 will give us 96. It should be 97, I mean. So I'm having 4i plus 9j over the square root of 97, which is option C. Then let's go to the question number 10. Say find the value of the value of the scalar k such that this and this are strictly perpendicular. Perpendicular also mean they are orthogonal. They also mean they are orthogonal. It means that the dot product of the two must be 0. That's what it means. The dot product of the two expressions must be 0. So I'm going to have 3i plus kg. What do I see? What am I seeing here? Okay. 4i minus j. If I should expand this, it'll give me 12 minus k is equals to 0. Therefore means that my k is 12, which is option C. Number 11. You say which of the, they gave us two vectors A and B. Say what is the relationship between A and B? So first of all, you need to test. We cannot determine whether they are parallel or they are perpendicular or they are identical. First of all, they are not identical. So let's check for perpendicular. That means the dot product must be 0. So let's find the dot product of A and B. A dot B will be what? I to I, which is 6i times 2i. That will give us 12. J to J minus 10. K to K is minus 2. 12 and minus 10. So direct, they are perpendicular, which is option B. So if they are not perpendicular, then I need to test for parallel, meaning the determinant of the two vectors must be 0. So we tested for perpendicular. That one is more easier to get first. That's why I went for perpendicular first before parallel. First of all, they are not identical. They can be identical if they have the same variables or they have the same absolute value, but they are not. So let's look at question 12. They gave us vector u is this, v is this. Say what geometrical property does the magnitude of this and this represent? It represents the area of parallelogram. That's what they represent. They represent the area of a parallelogram. That's option C. Now, they gave us three vector u, v, and w. Say evaluate the triple product this and this dot this. So we need to find the cross product of u and v. So by using determinant method, I'm going to have I, j, and k for the cross product of u and v. Here is 3, 4 minus 7. Here is minus 1, 2, and 1. So if I evaluate this determinant, I'm having I into 4 and 2 minus 7, 1 minus G into 3 and minus 1 minus 7, 1, then plus K into 3 minus 1, 4 and 2. So if I'm to evaluate this expression here, I'm going to have, let's solve it, I'm going to have I into this to D, which is 4 plus 14 minus G into 3 minus 7 plus K into 6 plus of 4. So what is it not giving me? Give me 18I plus 4G plus 10K. So multiply this with W as a dot product. The first one is cross times the dot W, which is a dot product. So I'm going to have everything here times I plus 2K. That's what I mean. So I to I, K to K, we don't have J. The J there is 0J. So 0 times anything is 0. So we're having 18 for I to I plus 10, which is J to J, plus 20. I mean 10 times 2 is 20. So having 18 plus 20, the answer is simply 38. So let's look at question 14. Question 14. So given the vector function u is a function of t, we have this evaluate as t tends to 0. So this fall under limit. So having lim of t tends to 2 of t squared plus 1i, t squared plus 1i plus exponential tg, then plus sine 3 pi tk as t tends to 0. So area I see t, I will substitute 2. Area I see t, I will substitute 2. So I'm going to have, here is now 2 squared plus 1 I plus exponential 2g plus sine 3 pi times 2k. So if I simplify, what am I having? I'm having 5i, because 2 squared is 4 plus 1, that is 5, plus exponential 2g. Then 2 times 3, that is 6. I'm having plus sine 6 pi k. You know, pi in trigonometry is 180 degrees. So what is 6 times 180? That will give us so let me multiply from my end. I know what 6 times 180 is and get the sine angle of it. So 6 times of 180 sine, that will give us 1080. What is the sine of that? Sine of that will give us 0. So sine 6 pi is 0. So our answer is just simply 5i plus exponential 2g. So you can try it out. What's the value of sine 6 pi? Pi is 180. Take note. You can try it out from your end. You discover that the whole thing here will blow up to 0. So our answer is just 5i plus exponential 2j, no k. K is 0 at that point, so option B. So we'll look at question 15. It said, let u and let u and v function of is this, that u dot v is equal to compute the derivative of d dt of u dot v, meaning we have to differentiate the variable in respect to t. So let's differentiate in respect to t. What am I going to have? I'm going to have d dt of u dot v, meaning we are differentiating with respect to t. Here will give us a 6t squared plus 2. If you follow the formula of derivation, nx n minus 1, if your y is f is power n. This is now your y prime or your dy ds. So the n will come down, subtract 1 from it. That's exactly what I just did here. So if you go by that, the answer is 6t squared plus 2, which is option A. Then let's look at question 16. Look at question 16. Say the velocity of a particle is given as this if the particles start from the origin, meaning at time 0. Find its position of rt when t is pi over 2. So the position, I mean the distance. So and they give us the velocity. So what we are going to do, we are going to write from everyday physics. We know that velocity is distance over time. So in place of v, I will put the arrow over the t. So I'm having the arrow over the t is equals to 2i plus cos tj minus sine tk. So let's make the arrow the subject formula. The arrow will give me 2i plus cos tj minus sine tk dt. So if I want to find arrow, I mean I need to integrate both sides. So integral of the arrow equals to integral 2i plus cos tj minus sine tk dt. So my arrow will give me what? Here will not 2ti. That's what we're having. If we integrate cos, what would we have when we integrate cos? That will give us sine tj. Then if we integrate sine, what are we having? Give us minus cos, which is plus cos tk plus c. That's what we're having, plus c. But we are here to get c. So what would be the value of c? Remember, c started from 0. What starts at 0? No distance has been covered, meaning arrow will be 0. And you are ct, I substitute 0. So if you should do that, we're going to have 0 as arrow equals to 2 bracket 0i plus sine 0j plus cos 0k plus c. So here with 0 plus 0 plus cos 0k will just give us k plus c. So if I should make k the subject formula, my k will give me minus c. So if k is minus c, what are we going to have at the end? We're going to have let me erase this part. So we're going to have arrow as a function of t will give me 2ti plus sine tj plus cos tk plus minus k. That's not the value of c. So you find the position when t is pi over 2. So anywhere you see t, now put pi over 2. So I'm going to have 2 dot pi over 2i plus sine pi over 2k plus cos pi over 2k minus k. So 2 can cancel 2. I'm left with just what? Pi I. So pi is 180, like I said earlier. 180 divided by 2 is 90. Sine 90 is what is 1. You just give me that is j, sorry. You just give me j. Then cos 90 is 0, so I'm just left with k minus k. So I'm having pi I plus j minus k. Pi I plus j minus k, which is option C. Okay, so that is solution to the question. So make sure you understand the concepts by knowing when to differentiate and when to integrate. So depending on the nature of the question, will tell you whether you have to integrate or you have to differentiate. Now, say find the value of the scalar gamma for which the pair 3 gamma I plus are perpendicular. So let me rewrite it clearly. We're having 3 gamma I plus 2g is perpendicular. That means dot 4i minus 3j, the result must be 0. So if you multiply, I'm going to have 12 gamma minus 6 equals to 0. So 12 gamma will give us 6. So gamma is simply 6 over 12. Our answer is 1 over 2, which is option A. So we didn't answer number 70. Let's go for it. It says for 3 arbitrary vectors A, B, and C, which of the following expression is defined as a triple product? As a triple product, which we've done that earlier, which is A times B dot C. That is option A. Let's go to the next. Number 19. Let's see what we have there. Number 19. Question say, if vector A is Z, vector B is Z, what is scalar multiplication of A and B that prove they are parallel? That prove they are parallel. So how do we determine a parallel vector? Remember we said for vector to be perpendicular, their dot product must be 0. But when it comes to parallel vector, so what do we have? In most cases, for 3 by 3, the determinant of the vector must be equal to 0. The determinant of the vector must be equal to 0. So let's check what happens if the vector is 2 by 2. So how do we find the determinant of two vectors such as that? So remember, for 2 by 2 we're having I, G. Then we can also include K. Okay, we can also include K. That means my A could be 2I minus J plus or minus 0K. It will have no effect. The minus will have no effect. And that means here will be 2 minus 1. Here is not 0. Then for B, you do the same thing. For B, we also add 0 to the vector, to the K, because there's no K given to us in that question. So let's add for B, I'm going to have minus 12I plus 6J plus 0K. So let's put it in the matrix and see. What are we going to have? We're going to have minus 12, 6, and 0. So from here, you apply the concept of determinants. The concept of determinant. So you take the first variable and you work with it. You also take the second variable and you work with it. Okay? So if you do that, we're going to have B to be 6A. B to be minus 1 over B, also 6A. So what is our A? Sorry, minus A. Our A will be minus B over 6. So we're having option B. So given the vector, say find the arrow dt. Let's differentiate the arrow over the t, which is velocity. I'm going to give minus 2 cos ti minus 2 sine ti. Then if I differentiate 2 sine will give us a 2 cos tj. If I differentiate tk, I just have a k. So I'm having minus 2 plus this and k. That's the result for the vector. So that is all we can take for vector and in dynamics. That is about vector and dynamics. If you have any question, you can ask us. You can post it on the comment section. We'll attend to it and get back to you. Subscribe, like, and comment on the channel. So we also have the area of geometry also. Also have area of geometry, and we also have dynamics in vector also. So this is dynamics in vector. Let's see how we can do with dynamics. If you have any question on the Scalar, please post it to us in the comment section as question. So let's look at question 1. You can reach us on YouTube, Facebook, Twitter, at STEMupAfrica. That's our YouTube channel. So like, share, and subscribe. Recommend the channel to your friends and others. So let's look at question number 1. Say a constant force F acting from time interval t0 to t1 exerts an impulse defined mathematically by which formula? We know impulse I is ft. That is ft. But the time changing from this is change the time from t0 to t1. So change mean will be final. This will become t into the final time minus the initial time. So change always takes place from final to initial. So that will give us option B. So let's look. So what is the standard SI unit for impulse and momentum? They are the same. Impulse is also known as impulse is also called change in momentum. And momentum itself is kilogram meter per second. So if therefore impulse can also be kilogram meter per second or Newton seconds for both of them, as the case may be. So the answer is option C. So let's go to question number 3. Say a particle is acted on by a constant force of this for 0.2 seconds. So compute the impulse vector exerted on the particle. Like we said, impulse I is ft. So what is the F? Our F is 2I minus 2J plus K times 0.2. 0.2 is scalar, while the impulse is in vector. So when scalar multiply vector, what we have is vector and not scalar. So 0.2 times 2I will give us 0.4I minus 0.4J plus 0.2K. So that's option A. Don't forget the unit. Impulse is Newton seconds. So let's look at question 4. Say a particle is acted upon by a variable force F. They give us the force. F is T square I plus 2TJ. Let's find the total impulse by integration. Total impulse by integration. We know that impulse is Ft. Is Ft. So I equals to integral of Ft. So if you integrate, I will give me what now? What's my F? My F is T square I plus 2tj dt. So that's our impulse. So if we integrate t square, which we integrate t square, what about having? Then don't forget the upper and lower limit from 2 to 0, given to us from the question here. So if we integrate it, what are we having? T raised to the power 3i over 3 plus, here we just give us t square plus a constant, so c. So when t is 2, what are we having? I'm going to have 8 over 3i plus 4j. 8 over 3i plus, okay, it's minus, not plus. We also carry minus. So here's minus, here's minus. So 8 over 3i plus minus 4j in Newton seconds, which is option B. Say the specific principle that impulse change equal to change in momentum is Newton's second law of motion. Newton's second law of motion. Okay. Question number 6. Say a particle of mass is moving in a straight line. It's acted upon by force which changes the speed from this to this. Calculate the impulse exacted. Remember we said impulse is change in momentum. So I need to get the velocity for 36 to convert to meter per second. So I'm having 36 times 1000 divide 60 times 60. So 0, 0, 0, 0. I'm having 10 meter per second from 36 kilometer per hour to 10 meter per second. I'll do the same thing for this is my u now. My v, I'll do the same thing, 54 times 1000 over 60 times 60, 0, 0, 0, 0. So we're having 54 times 10 divided by 36. That will give us 15. Final velocity is now 15 meter per second. So my impulse, we said earlier, it changed in momentum. I will change in momentum mass into v minus u. So which is, the mass is 10. We have 15 minus 10, which is 10 bracket 5. The answer will give us 50 Newton seconds. So let's look at question 7. Say define the linear momentum mathematically. Product of mass and its velocity, that is linear momentum. Product of mass and its velocity, that is option B. Then question 8, a mass, a 1000 kilogram car moving with a speed of it from brought to rest. After I cover a distance, when it's brought to rest, it simply means that the final velocity is 0. Meaning my initial velocity is the 80 km per hour, which I'll be 80 times 1000 over 60 times 60. 0, 0, 0, 0. That we're having 8000 divided by 36. 800 divided by 36. That will give us 200 over 9. So my v, my u, I mean, is now 200 over 9 meter per second. So final velocity is 0. Let's calculate the acceleration. Our a, we know that v is u plus 80 from first equation of motion. So my a now give me minus u over t if v is 0, minus u over t. But fortunately they gave us distance and not time. So what I will do now, I will apply the second formula that says v square is equals to u square plus 2ax. So this one is 0. Here is now 200 divided by 9 all squared plus 2 times a times 200. So We're having minus 400e equals to 200 square divided by 9. So let's divide. So if you divide carefully, you're going to have minus 100 over 81, which is deceleration. Deceleration is negative acceleration. So I have minus 100 over 81. So that is the value of the deceleration or the retardation. Depends, as the question may be. Then it says, so if you look at this question, it's an offshoot. It's an offshoot from the question number 8. Number 9 is an offshoot from it. The data are the same. 1,000 kilogram, 80 kilometer per hour, 200 meter. We are not asking us to find the force. So we've gotten the mass or the acceleration already. We know that force is what? Is ma from Newton's second law. So having 1,000 times the a, which is 200 over 81. So I'm not making a mistake. So 1,000 times 200 divided by 81. That will give us I need to get back the acceleration of the 100 over 81. So acceleration is 100 over 81, not 200. So I'm having 1,000 times 1,000 divided by 81. We're having 1234.56, approximately 6. Then number 10. Say in a projectile motion under horizontal and vertical axis, what are the standard acceleration components? Assume negligible resistance. So for AX, if you throw an object through the horizontal direction, we have two axes, x and y. Okay, so the resultant does not have nothing to do with gravity. So, but the vertical has something to do with gravity. So your ax is 0, your ay is a negative value. So an expression for the maximum height h is written as h max, written as u square sine square theta over 2g. U square sine square theta over 2g. That is option B. Then time of flight. Time of flight t is 2u sine theta over g. 2u sine theta over g, option B. So let's see question 13. Maximum range, arrow max is u square over g. Then at what angle? At 45 degrees. For you to obtain maximum range, you must project the particle at 45. That will now give you your sine 90 will be 1. Then at the end of the day, you have this as a result. U square over g, theta is 45. So option A is the correct answer. Then number 14. Number 14. You say a particle is projected with an initial velocity of this at an angle of this to the horizontal. So you calculate your horizontal displacement after 2 seconds. Horizontal displacement, which is our x, the formula is ut cos theta, which is 30 times 2 times cos 30, which is 60 times root 3 over 2 is cos 30. So cancel out, I'm having 30 root 3 meters. Number 15. It says for a pi drive of mass m2 hitting a stationary pi of mass m1, vertically downward with velocity u. Find the common velocity if it's elastic, inelastic impact. For inelastic, you're going to have m1 u1 plus m2 u2 equals to m1 plus m2 bracket v. But if you hit hitting a stationary mass, this is now 0. My m1 is 0, so the whole of this thing will blow up to 0 because it's stationary, no velocity is involved. So here will give me m2u equals to m1 plus m2 bracket v. So my v is now m2u over m1 plus m2, which is option C. Okay, so say from Newton's experimental law of direct impact state that the relative velocity of a particle along the line of center after impact can be related to that before the impact by this Raoult's expression. So this one I have to do with restitution. The E stands for the coefficient of restitution. So this part of the question is a little bit advanced. I don't know if your school have done that, but we're going to handle it and see. So the E, like I said, is a coefficient of restitution. So how does that relate in impulse and momentum? So let's check it out. So we know from relative velocity of two bodies, if two bodies traveling at different velocity, so relative velocity of the first body related to the second will become v2 minus v1. v2 minus v1. Okay, that's the relative velocity of separation. Then is equals to, or let me just take the formula directly. We have a restitution coefficient, which is our E, is simply v2 over v1 divided by u1 over u2. That is the formula of calculating restitution. So we are making v1 minus, so if I'm to make v1 over v2, subject formula now, what am I having? We're having v1 minus bracket v1 minus v2 over u1 minus u2. If I must write them, if they are traveling from stage 1 to stage 2, that's what I will have. So if I cross multiply, what am I having? I'm going to have v1 minus v2 also minus e into u1 minus u2. Okay, which is option B. So let's see. It said a mass of these, moving velocity of this, impact directly on another mass of these, moving in the same direction as this. It said the coefficient of restitution is 2 over 3. Find the velocity of the so we're having 2 over 3. If I should go by the formula, 2 over 3 equals to v2 minus v1. What's our v2 now? We don't know that, so we need to find v2. They gave us v1 and so I don't know what's v2. My v1 is 3. Then my u1 is okay, hold on. So let's see. My this is u1, this is u2. So we don't know v1 and v2. So let's get that. Let's get so I'm going to have m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So which is 3 times of 6 plus 5 times of 3 equals to 3v1 plus 5v2. So what are we having here? Here is 18 plus 15 equals 3v1 plus 5v2. That's what we have. So this will give me 33 plus 3v1 plus 5v2. So you can call that an equation 1 or so. Then they gave an equation of restitution, which is 2 over 3 equals to v2 over v1, v2 over v1 divided by u1, which is 6 minus u2, which is 3. So I'm having v2 minus v1 will give us 2, because here will give me 3. I can just strike out this 3. So if I make v1 the subject formula, what will I have? My v1 will be v2 minus 2. So if I substitute, I'm having 3 into v2 minus 2 plus 5v2 is equals to 33. So I'm having 3v2 minus 6 plus 5v2 equals to 33. So for correct like terms, I'm going to have 8v2 is equals to 33 plus of 6. What are we having? That will give us 39. So 39 divided by 8 will give us what? 39 divided by 8. That will give us 4. Okay, it's a whole number. 39 divided by 8. So we're having 39. How many whole number will be there? That is this is 32, which is B. I'm sorry, it's B. So that's how to apply the concept of coefficient of restitution. Please take notes. So let's go to question 18. See, Bob Marzi is traveling horizontally at this, strikes a wall at right angle and rebounds with this. Calculate the impulse. So one is important, sometimes it's good you sketch the diagram to know the direction. This boy is traveling like this. He hit the wall at right angle, meaning as perpendicular at and travel back. First one was 6. He moved back at 4. The same ball. Move back at 4. The mass of the ball is 200. So you can see this and this are traveling in opposite direction. So change in momentum is also the same thing as impulse. We discussed that earlier, which is m bracket v minus u. So this is the mass now. Convert it to kilogram. That will give us 0.2 kilogram. So if I substitute, I'm going to have 0.2 into, I'm having 6 minus 4, negative sign, which is minus 0.2 bracket 10. The answer will give us minus 2 Newton seconds. Minus 2 Newton. So although there's supposed to be negative sign, this option is supposed to be minus this option. So don't forget to subscribe, like, and share. STEMupAfrica. We have other videos that you might find interesting. So stick to the channel to benefit all this. So let's go to number 18, 19, and 20. Number 19 said a particle is acted by a force of this. From this to this, compute the total impulse delivered by integration. They gave us the force. They didn't give us the impulse. As you know, impulse now, I, will be the integral of upper limit is now 4, lower limit is 2, of f dt, which is 4 to 2 into 2t square minus 1 I plus 5t raised to the power 3 j all dt. So if I integrate this, what am I having? I'm going to have 2t raised to the power 3 over 3 minus t I plus 5t raised to the power 4 over 4 plus c. I'll put my upper and lower limit. So that means I first of all substitute 4 as a value, subtract it from when I substitute 2 as a value. So you can do, if I do that one, I'm going to have 2 brackets 4 raised to the power 3 over 3 minus 4 plus, we could have also which also have a 5 raised to the power 4. We have 5 bracket 4 raised to the power 4 over 4. Then minus, when it is 2, I'm having 2 bracket 2 raised to the power 3 over 3 minus 2 plus 5 into 2 raised to the power 4 over 4. So this is what we have. If you are to actually simplify it the way it ought to be simplified. So all you need to do now is to, what is 4 raised to the power 3? That should give us 64 times 2. That is 128. And to have 128 over 3 minus 4 plus, that here will just give us 5 raised to the power 4 divided by 4. 1 4 will remove 1 4. We are left with 64 times 5, 320. Minus, we'll do the same thing here. 2 raised to the power 3 is 8 times 2, that is 16 over 3 minus 2 plus 2 raised to the power 4, 16 divided by 4 is 4, which is 20. So if I take LCM here, what will I have? I'm going to have my LCM here will be 3. Here is now 128 minus 12 plus 960 minus, here is now 16 minus 6 plus 60 over 3. So let's add the first number. 128 minus 12 minus 12 so don't forget, this is this one is I, this one for I, this one for J, then this is I, this is J. Don't forget that. So the whole of this is I, J, I, J. So here is I, so in J, I, J. So we're having 128 minus minus 3. That will give us 125 I over 3 plus 96 J over 3 minus, here is 16, that is 10 I over 3 plus 60 J over 3. So I will not deal with 125 and 10 because both of them is II. That will give us a 125 minus 10. That will give us 115I over 3. That will give us a 96 minus 60, 36 J over 3. So 115 divided by 3 will give us what? I'm having 115. 36 divided by 3 is 12. Let's see. I think there's answer to this, but you can check it out yourself and see if you have an answer. But this is procedure. Then let's see number 20. Let's see number 20. Number 20, we have A particle of mass this moving in a straight line at this is acted upon by a direct retardating impulse of magnitude this. Find the new speed. We know that impulse is also change in momentum. I equals to change in p, which is m bracket v minus u. So the impulse now, which is change in momentum, is 550 equals to 25 delta v. What's my delta v is 550 divided by 25. What are we having? That will give us 22 from this end. So, but they gave us, we know that v is v minus u, it gave us 22. Okay, so our, see, traveling now, this is first speed, which is the final, then retardated will be initial. So, ideally, we're supposed to have u minus v equals to minus 22. Yes, because it's retardating. So what is our v now? Is 10. So let's look for the u's. I'm having u equals to minus 22 plus 10. U will give us a minus 12 meter per second, which is option C. So that is all about vector statics and dynamics. So let's see. Yeah, this is coordinate geometry under circle. So what is the standard geometric definition of a circle? When there's have equal or a fixed point from the center. When the circle is a locus of a point that has equal distance or a constant distance from the center. That center is called the fixed point or the fixed line from a fixed point. The outside is B. That's the definition of a circle. Then number 2 is to find the equation of a circle. Whose center is this and radius is this? The equation of a circle is written as x minus a squared plus y minus b squared is equals to r squared. So the a and b are the centers, and the center is given to us as minus 2 and 3. So the minus 2 is the a and 3 is the b. So I'm going to have x plus 2 now instead of minus 2 plus y minus 3 now is equals to 3 squared. So if I expand the first one, I'm going to have x squared plus 4x plus 4 plus y squared minus 6y plus 9 is equals to 9. Okay, so 9 and 9 will just remove themselves. So if I rearrange, I'm having x squared plus y squared plus 4x minus 6y is equals to 0. Plus 4, I mean, is equals to 0, which is this 4 here. So the answer is x squared plus y squared plus 4x minus 6y plus 4, which is option B. So which of the following conditions is not a required properties for a general second degree equation of a ray circle? Second degree, so it must contain x squared and y squared, which is true. Coefficient of x squared and y must be equal, very true. And there must be a non-zero entity of x, y. That is not true. There must be a non-zero. No, that is not true. So the option is B. C, I mean to say. Now, question 4. To find the center and radius of a circle of this expression. So let's see. The expression given to us as 3x squared plus 3y squared minus 6x plus 9y. I will transfer the 1 to become positive 1. So I will divide both sides by the coefficient of x squared and y squared, which is 3, I'm going to have x squared plus y squared minus 2x plus 3y is equals to 1 over 3. So I will arrange to apply implicit function. I'm having complete the square, x squared minus 2x plus y squared plus 3y is equals to 1 over 3. So if I apply the concept of complete the square here, I'm going to have x minus 1 squared. Here will give me y plus 3 over 2 squared is equals to 1 over 3 plus 1 plus 9 over 4. I'm squaring this and this. So the LCM here will give me 12. Here is now 4 plus 12 plus 27. What is that? 27 plus 12 plus 4, that will give us 43. So I'm having x minus 1 squared y plus 3 over 2 squared is equals to 43 over 12. So the centers now, if I compare with the equation of circle A, x minus a squared plus y minus b squared is equals to r squared. So my a is 1, my b is minus 3 over 2, and the radius is now the square root of 43 over 12. So I'm having 1 comma minus 3 over 2 square root of 43 over 12, which is option A. So let's go to question 5. Say determine why this equation does not represent a circle. So determine why this equation does not represent a circle. First of all, the equation of x and y must be the same. So let's see why it's not a circle. We're going to have just as the first one, divided through by equation of x and y, I'm going to have x squared plus y squared minus 2x plus 6 over 5 is equals to minus 25. 6 over 5y. So if I rearrange and apply complete the square, I'm going to have x minus 1 squared equals to minus 25 plus 1 plus 36 over 25. Then what are we having? We are going to have x minus 1 squared plus y plus 3 over 5 squared equals to, here is 9 over 25. I'm now having minus 24 plus 9 over 25. So if you go by that, the radius will give you a negative value. The radius will be a negative value. So that defies the logic of a circle. You calculate the s and give a negative value, yes. That defies the logic of a circle. So let's see number 6. Say find the equation of diameter. That one is straightforward. You'll have x minus x1, x minus x2 plus y minus y1, y minus y2 is equals to 0. This is how you determine the equation of a diameter. The first coordinate, you label it as x1, y1. Second coordinate, label it as x2, y2. So if I should go by that standard, I'm going to have x plus 1, x minus 2 plus y minus 2, y plus 3 is equals to 0. So if we expand, what will we have? I'm going to have x squared minus x minus 2 y squared plus y minus 6 equals to 0. So I'm having x squared plus y squared minus x plus y minus 8 equals to 0. So which is option B. So let's look at question 7. Look at question 7. It said find the equation of a tangent that passes through these points on the circumference. So to do so, I'll first of all want to go through a long process. I'll first of all find the y dx using an implicit function. So if I differentiate x squared, that will give me 2x plus 2y dy dx minus 4 minus 6 dy dx is equals to 0. So my dy dx will be what? If you simplify and make dy dx subject formula, I'm going to have 4 minus 2x over 2y minus 6. So when x is 1, y is 6, so that we're having 4 minus 2, here is 12 minus 6, which is 2 over 12. My dy dx now, which is the gradient, is 1 over 6. 2 over 6, that will give us 1 over 3. Our gradient is now 1 over 3. So if I simply take equation of line, y minus y1 equals to m x minus x1. So y minus 6 is equals to 1 over 3 x minus 1. By cross multiply, I have it 3y minus 18 equals to x minus 1. So I'm having 3y minus x minus 17 equals to 0, so which is 3y minus x equals to 17. Answer is A. So let's check question 8. Let's look at question 8. So let x and y be a function of this to be a circle if the arbitrary points h and k satisfy that potential k is less than 0. The points are what? Outside the circle, in the circumference of the circle, inside the circle, at the center of the circle, exclusively no. Inside the circle, that should be the point. They are inside the circle. If you find the position of this point, so if s is 5, y is 2, what are we having? We're going to have 25 plus 4 minus 15 plus 8. Let's see if it will give us 12. 25 minus 4 plus 25 plus 4 minus 15 plus 8. It gave us 22, not 12. So the point will lie outside the circle. So we say find the length of the tangent. If you have a circle such as this, a tangent to the circle from the center, this is the length of the tangent. Here is the center, so here is the point. So here is our radius. Okay, so let's see how we get the length of the tangent. First of all, we need to get the radius and the center. So if we apply the concept of implicit completing the square, I'm having x squared minus 2x plus y squared is equals to 8. Here is now x minus 1 all squared equals to 8 plus of 1. That will give me 9. So what is the radius now? Radius will give me 3. So the centers are now 0 and 1. And the point is 4 comma minus 2. Okay, so if you apply now distance, here is now here is right angle, so each side is now the center. Now is what? The center is 1 comma 0. So what is the distance between the centers? Let me erase for clarity. So I'm having 4 minus 1 squared, then 2 minus 0 squared, which is 9 plus 4. That will give me 13. Okay, so what is now the radius? The radius is 3. So the L now, I'm going to have x squared to be which is this point, the whole of this is 13, radius is 3. I'm going to have 13 square minus 3 square. So once it's okay, just 13 minus 3 minus 9, that is 4. Square root of 4 is 2. There's no technical. Yes, already. Yes, we didn't take the square root here, so remain as a square. So here is square also. We didn't take the square root. Let's call it t, tangent point, t square. So there's no square here. So you have a 13 minus 9, which is 4. Square root of 4 is 2. Then number 11. Let's see what we have there. So find the equation of tangent that pass through this point, the standard circle of this. So if you find your using implicit function, I'm going to have 2x plus 2y dy dx is equals to 0. So our dy dx will give us minus 2x over 2y, which is simply minus x over y. They give us the points minus 2 and 11, which is 2 over 11. So if you apply the formula x minus x, y minus y1, which is y minus 11, equals to 2 over 11 x minus 2. So I'll give us 11y minus 121 is equals to 2x minus 4. So going to give us 11y minus 2x is equals to, this is 1 to 5. So 11y, can break it down to 7, 4. Check the next option. So we're going to have option D as our results. So find the center radius, the same implicit function. I'm going to have, by rearranging, x minus x squared minus 6x plus y squared minus 8y equals to minus 5. So if I apply complete the square, here become x minus 3 all squared. Here become y minus 4 all squared equals to minus 5 plus 9 plus 16. That will give us 20. So the center is 3 and 4. Radius is square root of 20, which is B. So which of the following define the normal to a circle? Normal and circle are always perpendicular to each other. That is, they must be perpendicular. Boundary called normal and tangent are perpendicular. Perpendicular is tangent point. Yes, normal and tangent are always perpendicular. Number 14. It says find the standard equation of circle from the origin. The radius is given. From the origin, the center is A and B is 0. We'll just be left with x squared plus y squared equals to 7 squared, which is 49. Option C. Then number 15, you say if this point is tested against this circle, the power of the point is minus 17. Mathematically confirm that it lies outside the circle, inside the circle. The circle has an imaginary radius. That is true. because it gave us negative value. So find the equation if the center is given and the radius is given. So we have x minus a, my a which is plus 1 squared, y plus 4 squared equals to 3 squared. So that will give me x squared plus 2x plus 1 plus y squared plus 8y plus 16 equals to 9. So if you rearrange, I'm having x squared plus y squared plus 2x plus 8y. Here it says 17 minus 9, that's plus 8 equals to 0. X squared plus y squared plus 8y plus 8, which is option A. Then let's check number 17. Let's check number 17 and see what we have there. So find the general equation of a circle disc, which are coordinates of the center. Coordinate of the center is should be minus f and the minus gy. So we have x squared plus 2fx plus y squared plus 2gy equals to minus c. So take half a square, so I'm going to have a minus f and minus g. Option B. If the circle pass through the origins, must satisfy the value of the common constant c. Okay. Pass through the origin meaning s and y is 0, so c will be what? Will be 0. C will be 0. C is 0. Then number 19. So you find the equation of normal. You find the equation of normal to this point. So it's the same manner we find my divide here using implicit function. I'm having 2x plus 2y dy dx minus 2 minus dy dx is equals to 0. So my dy dx will simply give me 2 minus 2x over 2y minus 1. So the x is minus 1, y is minus 3. So I'm going to have 2 plus 2 over minus 6 minus 1, which is minus 4 over 7. Okay, so for equation to be normal, the second gradient is minus 1 over the first gradient, which is minus 7 over minus 4. The answer will give us 7 over 4 as the gradient of the normal. So with that, I can simplify the equation now. Y minus y1 equals to m into x minus x1. So let's see what we have from here. I'm having y plus 3 equals to 7 over 4 into x plus 1. So if I simplify by cross multiplying, I'm going to have 4y plus 12 equals to 7x plus 7. So that will give us 4y minus 7x plus 5 equals to 0. So there is no clear answer, but this one looks similar with typing error. So question 20, you will do that and post the answer on the comment section. Like I said, this is STEMupAfrica. Like, share, and comment. Recommend the channel to friends and family members. Thank you for watching. If you have any question, you can communicate it to us through the comment section.